Let's look at this question. What is the smallest positive integer that has 8, 30, and 54 as factors? Okay, so this is what, so we are looking for the smallest positive integer that has 8, 30, and 54 as factors. We are not looking for the greatest common divisor. Greatest common divisor divides these, but you're looking for the smallest number that each of these are factors of. So probably LCM would do that, right? So I think that's what it is. So 8 is 2 cubed, and 30 is 2 times 3 times 5, and 54 is going to be 2 times 27, which is 3 cubed. So if you look at the least common multiple, 2, 2, 2, and going to be 2 is the GCD, in fact. So the least common multiple is going to be 2 cubed times 3 cubed times 5. Okay, so 1080. So if you look at 1080, you can check 8 divides 1080, 30 divides 1080, and 54 is like 20. 54 times 20 is 1080. So that's what it is. So that's a simple question. Here is another one. 2 square times 4 square times 8 square times 16 square times 1024 square. 1024 happens to be 2 to the power 10. 16 is 2 to the power 4, and 8 is 2 to the power 3. 4 is 2 to the power 2. So if you see 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 10. So if you, in fact, convert all those to powers of 2, then what do you get? You get 4 becomes 2 square, right? So 4 square becomes 2 square square. So 4 square is 2 square square. 8 square is 2 cube square. 16 square is 2 to the power 4 square. And 1024 square is 2 to the power 10 square. So if you combine all this and then simplify, this is 2 to the power 2 times 2, 3 times 2, 4 times 2, 10 times 2. So 2 to the power becomes 2 plus 4 plus 6 plus 8 plus 20. So if you look at this, you can take 2 out common. So it's 1 plus 2 plus 3 up to 10. So we know sum of the first 10 numbers is what? 10 times 11 over 2? It's 110 over 2. But then you have 2 out, so 2 to the power 110, right? So that's how you look at it. In fact, if I can show you quickly, it was 2 square plus 2 to the power 4, 2 to the power 6, 2 to the power 8, and so on, 2 to the power 20. So this is going to be 2 to the power 2 plus 4 plus 6 plus 8, all the way up to 20. And we know that this one is 2 times 1 plus 2 plus 3 up to 10. And this is 2 times, this sum is going to be n times n plus 1 over 2. And the 2 cancels. That's how you get 2 to the power 110. Alright? So that's how you get 2 to the power 110. And I'll skip the third one. I don't think I've taught you what is CU of Eratosthenes. Some of you might have already heard it, but whenever I talk about it, then I will come back to those kind of questions. Here, there are 2 clocks on the wall. The first clock runs fast, taking 54 minutes for the minute hand to make 1 revolution. The second clock runs slow, taking 63 minutes to make 1 revolution. If both clocks start with their minute hands pointing straight up, it's pointing up, how many times will it elapse before they again simultaneously point up? So if you look at all these questions, they all seem to be kind of number related. So let's see how you go. So 54 and 63. The key is to find the least common multiple. Why you find the least common multiple? Because that's the only when there is some, when there is a numerical value that both of these can be a multiple of, only then both the minute hands is going to be up. So if you look at the LCM of 54 and 63, this is 9 times 6, and this is 9 times 7, right? So let me go back here. LCM of 63 and 54. This is 9 times 7. This is 9 times 6. So we know that the 9 is the GCD, right? So the greatest common multiple is 9 times 7 times 6. I think. Is it? Okay. So that is going to be 63 times 6. 378, right? So, in other words, the clock, oops. Let's see if I can come back here and draw a circle. So if we have, this is the clock, then the minute hands is up. The other clock is also, the minute hand is up like this. So it will keep coming up after 54, multiple of 54, right? So what multiple of 54? 63 multiple of 54. And the other one is 54 multiple of 63. So if you look at it that way, then it's easy to understand. So the 378 happens to be 54 times 9. Yeah, 54 times 63. Is it? No, 54 times 7. Yeah. So anyway, approximately after 6.3 hours, which is 378 minutes is 6.3 hours approximately. Both of them will have the minute hand up at the same time. Okay, so that's what it is. Let me see if I can bring another set of questions for you guys. Okay, a farmer has 100 feet of fence with which to fence off his garden. He wishes to enclose the largest area possible for his garden, and he doesn't know what shape: triangle shape, equilateral triangle, square shape, or circle shape. So 100 feet fence, equilateral triangle, you have to divide by 3, right? So let's see how to solve the first one. So if it's an equilateral triangle, side length is 100 over 3 because the total fence length is 100 feet. So each side will have 100 over 3. So if each side is 100 over 3, what is the height? What's going to be the height? The height is going to be, let's see if I have it here. The height, okay. If the length is b, half length is b over 2, so this length is b, so it's going to be b squared minus b squared over 4, so this is root 3, square root of 3b over 2. That's how you find the height, right? So, so square root of 3b over 2, b is 100 over 3, so if you simplify, you get 50 square root of 3 over 3. So triangle area is half base, which is 100 over 3, times 50 square root of 3 over 3. So if you simplify, this is approximately 481 square feet. If it's a square, each side will be 25. And so the square has a larger area than the equilateral triangle. So far, square is the winner. What happens to the circle? The radius of the circle is the total circumference. The circumference is what? 100, right? So that's what is the total circumference, because 100 feet is the fence. So 100 over 2 pi is going to be the radius. So what's the area then? Pi times 100 square, which is 10,000 over 4 pi square. So 10,000 over 4 is 2,500. Pi over pi square is going to be over pi. You know that pi is almost like 3 point something, right? So it's going to be a larger value than 625. So the circle happens to be the winner. Circle is by far the best choice. In fact, it can be shown with the, if you go to, when you go to high school, you see with the method of calculus of variations that the circle is the best choice of any planar figure. Okay, the next question is kind of interesting. A rectangular doghouse measures 6 feet by 2 feet. The dog is tied to one corner of the doghouse with a 4 feet leash. What is the size of the area of the square in square feet that the dog can sweep out with this fully extended leash? Express your answer as a number multiplied by pi. Draw a picture. Okay, so we know that if the dog is tied here, the dog is tied right here in this corner. So this total length is 6, but the leash is only 4. So if it makes a circular path like this, it can only come up to 4, right? 4 feet. So the same way it comes 4 feet, 4, 4, 4, 4. And since this length is 2, it can only go up to 2. So up to here, this part is 3/4 of the circle of radius 4. So 3/4 of pi 4 square is this area. Now this small quadrant is, this length is 2, this length is 2. So this happens to be the 1/4 the circle of radius 2. So it's 1/4 pi 2 square. So this happens to be 12 pi. This happens to be pi. So the total area that the dog can, go around is 13 pi. I will stop here and resume with other questions.